Hello, my name is Sören Auer. I'm professor for data science and digital libraries at Leibniz University of Hanover and director of TIB, Leibniz Information Center for Science and Technology. Today I will talk about describing scholarly contributions semantically with the Open Research Knowledge Graph. If we look at how information flows changed in the digital area, we see that a number of publications don't exist anymore. For example, mail order catalogs, street maps, phone books, or even encyclopedias. How does it work today? We have e-commerce websites, we use digital navigation tools and communication tools. We have Wikipedia as an online encyclopedia. So the world of publishing and communication has profoundly changed. There are new means adapted to the new possibilities. For example, we can zoom into the information, we have more dynamics. The business model is completely changed. There is more focus on data, on interlinking of data, on services, search in the data. We have an integration from a large number of data sources, crowdsourcing, and data curation. These all play a crucial role. What about scholarly communication? Scholarly communication basically hasn't changed over the centuries. So if you look back in the 17th century, the philosophical transactions of the Royal Physical Society, the typography, the layout has changed over the years, and we now can, of course, access publications as PDF documents over the internet, but we still work with the same static publications. And imagine if we would have to use a mail order catalog, a street map, a phone book, an encyclopedia, which you get by email or which you download as a PDF scan. So we need to rethink the way how research is represented and communicated, and we currently face a number of challenges. If you look at scholarly communication, we have a monopolization by commercial actors, there's a reproducibility crisis, we have proliferation of publications, we have a deficiency of peer review. So these are all symptoms, from my perspective, of the inadequacy of the methods of scholarly communication which we are currently using. So, for example, how could we build a house of wisdom if we don't have nailed down the terminology, if we cannot describe and identify research problems, approaches, methods, characteristics, or evaluations? And if you look in other domains, for example, how could you build an engine or architecture house without properly defining the parts, the relationships, the materials, and the characteristics? So there's a lot of duplication and inefficiency currently in scholarly communication. We have a lack of transparency, information is hidden in text. We have a lack of integratability, different research results doesn't fit easily together. There's a lack of machine assistance, so this unstructured static documents is very hard to process or impossible to process. So we cannot use techniques like question answering. We have a lack of identifiability of concepts beyond metadata, of collaboration, and scientists lack overview. So they are basically looking for the needle in the haystack. So if you look, for example, on Google for the famous genome editing method CRISPR, you find almost 250,000 publications there. If you're then interested, how good is CRISPR with regard to precision, safety, or cost? What specifics does it have when you use it with insects? Or who has applied it to butterflies? Then you're completely lost in this big pile of publications. So how can we fix that? Actually, this idea of organizing scholarly communication, scientific information, tracks back to Vannevar Bush, who already shortly after World War II coined this idea of MEMEX. At that time, I would say a bit esoteric apparatus, which basically brings the information for a researcher at his fingertips from some kind of magic desk which stores all the scientific scholarly communication. And how can we implement and realize that? I think nowadays, today, we have the ingredients to realize one of our Bush's vision. So we have to identify the overarching concepts, the different artifacts and domain-specific concepts, and basically integrate and link them in a knowledge graph. So overarching concepts are research problems, definitions, research approaches, methods. Different artifacts are publications, data, software, image, audio, video, and then the domain-specific concepts like definitions, theorems, and proofs in mathematics, in physics, experiments, data, and models, or in chemistry, substances, structures, and reactions. So what we need is knowledge graphs which can capture this information, and currently we use knowledge graphs primarily for factual knowledge, for entities and relationships between these entities. But in research and scholarly communication, we have uncertainty and disagreement, we have varying semantic granularity, we have emergence, evolution, and provenance, and we have to integrate different existing domain models. At the same time, we need to maintain flexibility and simplicity. So I think we need to go to something like more cognitive knowledge graphs, which are as a fabric of knowledge molecules, which are compact, relatively simple structured units of knowledge, and which can be incrementally enriched, annotated, and interlinked, and use such kind of cognitive knowledge graphs to represent scholarly communication. If we compare that to the knowledge graphs we currently have, knowledge graphs currently capture real-world entities, entities are atomic, can add and delete facts, and we can enrich facts in collaborative settings. For scholarly communication, we need more also conceptual entities, like research approaches, for example. We need to interlink such descriptions with annotations and keep the provenance. We need to track the concept drift and varying aggregation levels, and have emerging semantics in this collaboration. So let me illustrate how we aim to realize that with an illustration of a bioRxiv publication, a practical guide to CRISPR-Cas genome editing in Lepidoptera, which is butterflies. So, and we envision that in addition to the publication, the knowledge graph is populated with information about research problems, about the methods, about what they were applied on, where the experimental data can be found. And once we create such a knowledge graph, we can integrate many of these small snippets of descriptions of research approaches, and use this knowledge base for assisting users, researchers in answering questions and exploring the graph. So there the research challenge is to provide intuitive exploration, leveraging these rich semantic representations and allow to answer natural language questions. So for example, you could ask a question, how do different genome editing techniques compare? And then by parsing this question, detecting the named entities and relationships, by constructing a formal query on the knowledge graph, executing the query, we could render the results to the user and implement something which is currently already popular with Amazon, Alexa, for example, or Google Now, which provide such question answering services for ordinary scenarios. As a result, we could then get a comparison of the state of the art, or a survey of research in a certain area, which basically gives us an overview, condensed overview of different approaches, how they compare, and their advantages and disadvantages. Now I would like to show you how we implement that in the Open Research Knowledge Graph. So one research problem which currently affects us all is the COVID-19 reproductive number, the so-called R0 value. And there were a number of studies published initially in China, later in Iran and Singapore and Italy about determining this reproductive number. So each publication contains 15, 20, 30 pages and describes in detail the method and the approaches. But in order to determine this R0 value, we need to get an overview. So what is the essence of these different studies? And the important information is the location where the study was performed, the study date, the R0 estimate, and the confidence interval. And we added this information to the Open Research Knowledge Graph. And you can see here such a comparative view of all these different studies, which gives you a condensed overview of these 31 studies. We can look at one particular study and then we see basically the contributions of this study. We can see that this individual information is represented in statements and in facts in the knowledge graph. And we can also edit that, so the possibility to crowdsource and to collaborate on the knowledge graph, and you can add or revise the values there and change it. All changes are tracked like in a wiki, and of course it's possible to add more information and to complement the knowledge graph with more information. As a result, we then get a graph representing not only the bibliographic metadata of a publication, but also the concrete contributions and the gist of a contribution, basically, of a paper, like here in that case, the R0 assessment for COVID-19, and along with confidence interval and the location where it was performed. And once we have this information, we can not only give such a tabular condensed overview, but we can also represent it as a bar chart or a combo chart, which indicates also the confidence interval. And that gives an epidemiologist a bird's eye view, basically, on the number of studies with at one glance. What about recent Open Research Knowledge Graph developments? I will give you some current updates which are currently under development or partially already also available. So the general architecture follows such a layered architecture. We have a graph database, Neo4j as a basis, and then on top different APIs, which are then used on the user interface to facilitate curation, the exploration, and the contribution. So one specific extension which we integrated recently are domain-specific templates for research contributions. So you basically can define a template, like for example, case fertility rate, the location and the time period, and this results in predefined forms which are generated to capture the contributions of a scientific publication. We also allow the alignment of the knowledge base with existing data sets. So here, for example, you see alignment with geonames. So when you search for locations which are defined in a template, it automatically offers you to link to the corresponding geonames resources. Another possibility is to integrate existing surveys into the Open Research Knowledge Graph. And there, Alan Öhlen developed a survey table extractor, which allows you to extract tables from existing survey PDF documents. So you basically can select the table and then extract and in a semi-automatic way reuse the information from this table. So it allows to resolve also the references from the table, and then you have a tabular editor which allows you to basically revise and curate the information extracted from that table for integration and import into the Open Research Knowledge Graph. Another tool which is currently developed by Allard is an annotator where you can annotate papers. You basically select parts of the paper and then you can associate them to with certain properties and thus create a semantic representation of the paper by annotating the PDF view. For example, describing the contribution, highlighting the materials, the methods, the problem, the results, or related work in the paper. And then, of course, in subsequent steps, these have to be further revised and represented in a more fine-grained way. We integrated a way to publish state-of-the-art comparisons. So once you created such a state-of-the-art comparisons, a tabular view of the state-of-the-art in a certain with regard to a certain research problem, you can also publish the state-of-the-art comparison with the DOI, and we envision to extend that further so that you have a proper formal publication also by integrating such a state-of-the-art comparison. We plan to organize research contributions along research problems in the graph. So we have a research problem browser integrated where you basically have a definition which can also come from Wikipedia. We have subproblems, we have associated research fields, superproblems, and then the particular publications contributing to solving this research problem. We also plan to integrate and highlight contributors and authors and giving basically an overview of who contributed and on the one hand to representing the information in the open research knowledge graph, on the other hand also to solving research challenges in that area. We are also integrating domain observatories. So these are basically observatories for a certain area, like a certain domain, which are curated by organizations. Here in that example, you see an observatory for indoor environmental perception and behavior, which is curated by the University Hospital of RWTH Aachen and Northwestern University, and you have certain contributors who help organizing this part of the knowledge graph related to that particular domain or research problem. And that will help organizations like research institutes, universities, research groups to showcase their contributions to the open research knowledge graph. Yeah, with this I want to conclude my talk, and of course we have a large team working on this open research knowledge graph, and we collaborate with a number of research groups, and we would be very excited to also collaborate with you. I think we need together reinvent scholarly communication. Knowledge graphs are perfect suited to capture research contributions in a structured and semantic way, making them human and machine interpretable, and that's very important. With the Open Research Knowledge Graph, we aim to establish a registry for such research contributions, semantic descriptions of research contributions, and curation and synergistic combination of human, expert, and machine intelligence. That's a challenge we want to tackle, but that's, from my perspective, also required that we integrate these different aspects, human, experts, and machine intelligence. Yeah, so please stay tuned. You'll find the Open Research Knowledge Graph under orkg.org, and we also have a Google group, and we would be really excited to have more collaborators, either on the software, on observatories, on curating, on demonstrating the open research roadgraph, outreaching to different communities, creating different showcases. So please let us know if you are